Hello and welcome to the live stream. My name is Stefano, and I would like to begin by gratefully acknowledging that Science World is located on the traditional and unceded Musqueam, Squamish, and Tsleil-Waututh village site of Sinnock, here in False Creek in Vancouver, British Columbia. Welcome! In today's live stream, we will be celebrating Acts of Clean. So many of you out there have been doing as part of BC Hydro's Acts of Clean Challenge. I'm very excited about this today. These include all sorts of little things that we can all do to make a big difference in a small way and improving the climate and reducing climate change, and of course, having a healthy planet. Joining me today, as well as yourselves, is my friend from BC Hydro, Mandy. Hi, Mandy.
Hi.
How are you today?
Pretty good. How's yourself?
I am very excited, and I'm very appreciative for you to be here today, both to celebrate the Acts of Clean and to help me with some of the demos that we're going to be doing today. A little honorary scientist with me.
Yeah, let's do it. 100%.
Awesome. We're going to be doing these science demos with each other, but also with you, because some of the information that you'll help us with and some of the ideas are going to help drive this show along. So let's start right there. Any of you that are in your rooms, in your classrooms, in your living rooms, whatever room you're in, whatever place you're in, let us know where that place is. Now, you can put that in the chat, and you can type that in. If you're a teacher in a classroom, you can type in the name of the school or the name of the city or the name of the classroom in the chat. And then we can do some shout outs to you throughout the presentation and come to you for some answers that we might need throughout the show. In fact, we have a very special classroom that decided they were willing to join us live, and we're going to introduce them right now. Let's bring them up here and welcome Ms. Seaver's class from Montgomery Middle School in Coquitlam. Hello. Hello. Amazing. This is great. The technology. We're streaming into classrooms and living rooms across the province, and we're literally getting to see and experience this with you today. Thanks for joining us.
Hi. Thank you for having us.
Ms. Severs, I'm going to ask you a quick question. I love getting input from students when I'm doing presentations, and we're going to be covering some extreme weather patterns as part of our live stream today. Can you maybe get some of your students to give me some ideas of some of the extreme weather patterns they are excited about or curious about that we can explore today?
Snow. Hands up. Snow. We got snow. Somebody's excited for snow.
Awesome.
Say again. Storms. Any sort of storms. They're really excited about storms.
Writing these down. Snow.
Ruben?
Like thunderstorms?
Any thunder and lightning storms.
Thunder, lightning, all right.
You're into that. Anything else? Anything recently over here? Yes? Hail. Ooh, hail's fun. Yeah.
All right, I got those. You got a lot of precipitation fanatics out there. That's fantastic.
Snowstorm.
Snowstorm? Okay, yep.
Great. I'll be checking in with you a little bit, and you can let us know what your experiences have been with the Acts of Clean as well. And I will probably check in with some more science questions for your excellent students out there. And thanks again for joining us. See you in a bit.
Wave, everybody.
The first thing I should do actually is clarify too that we're talking about extreme weather patterns, and weather and climate are a little bit different. Weather is sort of the everyday thing we see when we look out our window, and climate is what we measure over a long period of time. So something like snowstorm might be a weather pattern we get today. When we talk about climate, we're looking at trends across a long period of time. And many people think about things going forward with the acts that we do today can lead us forward into change later. It's a really fun way to think about it is this. If you went back in time right now, and you went to the many years ago, and you change one thing, many movies are about that, you see it, and you see the effect changing many years later. And that's how sort of climate change happens. The acts that we do now can help things in the future later, and we can do that to improve things. And the small changes that we do today can add up very quickly to bigger and better changes and positive changes, especially when we work together. Now, that brings me very much to this challenge that many of you participated in. Mandy, you and BC Hydro have been tracking some Acts of Clean. Tell me a little bit about the program and the challenges, please.
Yeah, so this fall we actually went and set out a 4-week challenge where we got people from all over British Columbia, all the way from like right here in Vancouver up to like Fort St. John's. My goodness, we actually gave you guys the challenge of just completing 10,000 acts of clean. You guys blew us out of the water. Oh my goodness. There was not just 20,000, we had 30,000 acts of clean that were completed this fall.
That's amazing. So you think that one person doing one thing is pretty impactful, but when you have 37,000 plus actions happening, that's definitely worth celebrating. And today, I believe we're going to also be celebrating the winners of it. Was it a contest?
Yeah, it was.
All right, so we're gonna have that towards the end of the show.
Yep.
Awesome.
100%.
I'm very excited about that. All right, so they presented 37,000 plus acts of clean, little things that made a big difference. They're broken down into multiple challenges.
Yeah, we actually had 4 challenges. So every week we gave you guys a new challenge. They included our Powered by Water challenge. We had conservation. We had commuting, like a clean commute, as well as sustainability.
Wonderful. I'm just in a quick moment to acknowledge all the fantastic students and teachers in the chat. Big shout out to Arrowview Elementary in Coquitlam Beach. We got visitors from Ladner. We've got Sullivan Heights Secondary School joining us today. Sacred Heart in Ladner as well. Vernon and the Okanagan. We've got a whole ton of you out there. And so thank you for mentioning that in the chat. And if you had an act of clean or a particular challenge that you really enjoyed throughout the presentation, just put it in there. If you did something about something we're talking about and you're like, we did this thing, we're really proud of it, put it in the chat. We'll celebrate you as well. Awesome. So you mentioned 4 of them, and the one that catches my ear first is conservation. Now, BC Hydro powers our province and is very well known for conserving that electricity.
Yeah.
Tell me a bit about that one.
Well, actually, with our conservation challenge, we saw 16,000 acts of clean that were done. And those are just really small acts, like turning off a light when you leave a room, or when you use an appliance, just making sure that you take that plug out, because all of those acts, they really do add up.
It's very true. Little things make a big difference. Some of the little things that can make a big difference is that little weather pattern that can have an effect on a long piece of the weather picture and create the climate change that we're talking about. Now, my class there, Ms. Seaver's class mentioned storms as one of them, and storms are often powered by wind and high and low pressure air. So hot and cold air, when they meet in the right place and time, often create storms. I was actually on the west coast of Vancouver Island a few weeks ago, and there were 100-kilometer-an-hour winds, and it was very powerful and a little bit frightening, in fact. But when we understand the weather, we can take the right steps to stay safe, like stay in a safe place. Here's the thing. Weather, like storms, are often created when we have high and low pressure systems meeting at the same time. And they often create something like a tornado. In fact, many of you may have noticed in the news lately, we had a weather pattern, a tornado, that happened just off the coast here. It touched down in Vancouver, out by the university, I believe. Did anybody see the footage of that? Oh, looks like Una said we talked about the rare tornado that hit us. And that's very, very true. It's a rare thing. So when we're noticing these trends that are new to us, like the heat dome in the summer or this tornado, these are the trends that we're noticing. We're making sure we want to reduce those big events by making these small acts today. So tornadoes are pretty powerful. How they work is that when the air comes together, and we're going to do a quick demo with a tornado right now. Mandy has some equipment I've set her up with. You have a tornado machine, and we're going to be very safe with that in our studio here. So when air is spinning in a circle, there's hot and cold air meeting, and we're going to see a tornado. Are you all ready for this out there in live stream land? All right, Mandy, turn on our tornado machine. Ladies and gentlemen, a tornado.
I don't really see anything.
You're right. We don't see a tornado. People in the chat, maybe check in with Miss Seavers' class. Not seeing much of a tornado here. Any reason why we might not be seeing a tornado?
Water on the side.
Taryn, what do we need?
There's water on the side.
We need water?
What?
Is that what you're saying?
Yeah, because there's water on the side. You can't see it now. Maybe when?
There's water on the sides? Can you see that?
It's like tiny water.
Oh, you see something hiding on the side of the screen. Maybe it's just.
Oh, they saw some water on the screen next to Mandy.
What do we need for a tornado to?
You need fuel.
We need.
What about wind?
We need wind. Wind.
You need oxygen, fuel, and a spark.
That's for a fire.
Yeah.
Hang on. I'm hearing all kinds of stuff from your class, and I'm loving it completely. So I've heard that we can't see it because nothing's in it, and that's absolutely true. Tornadoes are high-powered winds. Sometimes they do pick up water. That's true, and depending on where it is around the planet, we might name that a cyclone or a different name for it. But essentially, it's that spinning force that's picking something up. It can pick up dust. It can pick up water. It can pick up cows. A cow tornado. I hope I never see one. But I heard also some ingredients for fire, which is very interesting because last summer we had a lot, I mentioned the heat dome, of very warm temperatures, and it created a lot of forest fires. And within a forest fire, sometimes that fire can actually create a fire tornado. So Mandy, that's probably the most exciting thing you could probably do with that piece of equipment is add fire. Let's, Ms. Seaver's class, would your class like to see a fire tornado?
You want to see a fire tornado?
Yeah!
Nobody? Nobody then?
Nobody. No.
Nobody? Just kidding. It sounds like in the chat, oh, you can't hear necessarily. We'll make sure we hear everything from the classroom a little bit better here on the chat here. Thank you for those notes. If anybody out in the chat want to see a fire tornado? If you do, make some fire emojis or some type some fire tornadoes. Let's get some enthusiasm here. We're not just going to make a fire tornado for it without some enthusiasm. That means you too, Ms. Seaver's class. All right. Here we go. So Mandy, what I'm going to need you to do. The class did tell us the 3 ingredients they needed for a fire. I heard that. They said sparks or a heat source. They said fuel. And they said oxygen. We have oxygen in the room, and there's some equipment there in front of you. If you just want to make a fire tornado for us, that would be fantastic. Go for it, Mandy.
I don't think I'm actually properly really trained to do like anything with fire.
Well, I will admit I didn't necessarily expect to be doing a fire tornado, but we have tricks up our sleeve here at Science, so we can solve this properly. We have a lot of people that want to see this fire tornado. Amazing. So Mandy, how about I'll cut to center stage. I've got a friend of mine, Brian, who's definitely equipped and has got the safety parameters in place for doing that. There he is at center stage. There's some sand to put out the fire that would remove the oxygen from the fire. There's that device, much like ours. And here's his fuel source. There's some fuel source going in right there. And that is isopropanol. And he's going to use... He's got his fire gloves. There's his fire. He's going to light it up. There we got our fire, and he's going to spin it. He's got the oxygen, obviously. And here's our fire. Ladies and gentlemen, a fire tornado. Not really tornado-y. It's just a turning fire. Now, the difference here, of course, is that we're not just turning fire. It's about the air that is spinning. So what Brian's going to do here is going to put that cage over top, just like Mandy had. And when he puts that cage over top, it's going to heat the air inside that cage. And as it's spinning, it's going to draw that cold air from the bottom and fire tornado! Yes! Woo-hoo! Amazing! Nice job, Brian. What is he doing? Stop. Brian, no. Reverse fire tornado? Amazing! I didn't expect a reverse fire tornado when I tuned into the live stream today. I hope you did. Pretty exciting. There it is. And of course, you have those 3 ingredients that make fire. You're going to need those to put out the fire as well. So you remove one of those 3 elements and that fire will cease to be. So he's going to probably take that bucket of sand and put it on top of the fire to remove the oxygen. Access to the fire. Here we go. And, oh, very clever, Brian. Very nicely done. Congratulations. Thank you very much, Brian, for helping us do a fire tornado without any dangerous fire in the room here. Of course, when you have fire or when you burn any kind of substance, it creates a byproduct, and that byproduct can go into the air. I've got some great comments from the chat there. Very nice. But anytime you burn anything, basically it creates byproducts such as carbon dioxide or other greenhouse gases. And so that kind of leads us to one of our acts of clean challenges, doesn't it, Mandy?
Yeah. So we had, as part of our challenge, the Clean Commute Challenge, which we really focused on how we do reducing our greenhouse gases as we go and do our daily commute. So we had you guys focus more on walking or taking your bike to school. Yeah.
Walking and taking your bike to school is a great solution. I'm going to check in with Ms. Seaver's class and see if they took on that particular challenge and if they had any challenges with that. Ms. Seaver's class, did any of your students, and also in the chat, please feel free to add this along. We love reading what you're doing. Did you have any success with choosing any elements in that challenge?
So for this was for the reducing GHDs. This is the walking to school one. Is that
Yes,
the one?
absolutely.
Yeah, we have quite a few students in our class who already walk to school. And we also had some students who were able to share a fact about EVs, which was kind of cool. And so that earned them a point for that. Maybe you can confirm if this is true. We had N share with us that most electric vehicles have 2 batteries in them, one to power the vehicle, but the other one for all the electronics and
Yeah, a bigger
whatnot.
one and a smaller
A
one.
bigger one.
I have heard that exact thing. That is, that I have heard that. And of course, the electronic vehicle technology is improving constantly, as well as hybrid technology. And those elements have to be considered very carefully because you don't want to be stranded. And there's lots of things to power, both the electronics inside, as you mentioned, as well as the vehicle itself. So yeah, there's a lot of technology that goes into that. I wonder, do all your students have electric vehicles?
Pardon me?
All your students probably don't have electric vehicles, am I right?
How many people in the class have an electric vehicle? Put your hand up. I think it was 1, 2, 3, 4, 5 students in our class.
And that's not always a choice that we can make very easily, especially as younger citizens. But definitely there's little things like bicycling to work or walking, as Mandy pointed out, and that's a great way to get the points in the challenges, but also to make a difference in small steps. In fact, one of the things we have here at Science World, if you visited recently, is as you walk in, you may notice a bike path that crosses right in front of us along False Creek. And we have a bike counter, and it's our way. There's our clean commute. This 6,000 acts of clean. Is that right, Mandy?
Yeah, that's right.
Very cool. And we have a bike path that counts the bicycles that pass. There's one now. We're at 718. This is earlier today. And 719. Look at that. And that's a great way you can actually celebrate every time you bicycle around. And that's a infrastructure around the whole city. The bike path didn't start with one at all. It started with one small act. It started with 1 or 2 bike paths. And now there's that map there that shows the infrastructure and the grid that is across the city. So you're not alone out there doing this. If you'd like to challenge yourselves to learn about the different bike paths, you can have a group with your school or your work to create a team that you can celebrate among yourselves these biking to work or biking to school challenges. For example, at Science World, we have the Angular Momentum team that bicycles together, or not together, but they keep track of their stats together for how much they bicycle to work. And it's a good way to encourage each other. Now, many people bicycle in the rain and in the shine, and the shine part is easy on a sunny day. On the rainy days, it's a little bit harder. Mandy, do you ever bicycle in the rain?
No.
No, I don't have the gear. I will admit.
Umbrella, you know.
I'm going to challenge myself to get some more rain pants and feel more comfortable in that situation. And rain is all around us. And another extreme weather pattern that was not mentioned yet, but I'd like to offer to the crowd listening, is acid rain. Now, acid rain is on those rainy days, not something we need to worry about here in Vancouver, thankfully, but it is a weather pattern when the rain is too much acidity, and that can affect things like plants, ecosystems, animals, and down the line, ourselves as well, and our oceans too. Now, Mandy, this is a demo that I think you can help me with. It doesn't involve fire, we've talked you through it. So why don't you help me out with this demonstration about acid rain?
Sure. So should I grab this jug of water?
Yes, please grab that jug of water and bring it to center there. There we go. Audience can see it now shortly. There we are. Let me just get Andy on camera there for me. Thank you. There we go. So Mandy's got some nice clean water. We're not going to bicycle through that today. We're just going to do some experiments. We've got nice clean water and we've got nice clean air in the room. So what I'm going to get you to do is add a chemical that is going to tell us if that water changes in any way while we do this experiment. The chemical she's working with is called bromothymol blue. I've got some right here, and she's pouring some right now. And that is an indicator that's going to tell us if that water gets acidic in any way. Acid rain, of course, is, where does acid rain come from? Is this from the grade 6-8 students are asking us this. Thanks, Mandy, you're doing fantastic. Well, I'm going to answer that question while Mandy's working on this. is that when the rain comes down through our atmosphere, if there are too many pollutants in that air, it's going to filter those pollutants into that rainwater. And that's what we're doing right now. We're going to actually put some carbon dioxide into that water. First, we're going to test it with the air in the room, and then we're going to see if we can make some acidic rainwater or water. All right, Mandy, you've got some air from the room through that pump, and just go ahead and pump some of that air and see if anything changes. First, we're going to do a baseline test. And audience out there, I want you to look if there's anything happening. If you see something, put it in the chat. I see bubbles, for example. Bubbles in the chat. Nothing much is changing. So what we're going to do is we're going to now switch it. Instead of the air in the room, we're going to put the air from your lungs, Mandy, into the water. Now, in the chat, you probably know this. When we inhale the air that is mostly made of nitrogen, oxygen, and other trace gases, we exhale a lot of this other gas. Can you put it in the chat and let me know what that gas that we're exhaling is, whether that's a classroom putting it in or audience members? Let me know what that gas that we're exhaling is, while Mandy is going to be exhaling. All right, so you're still observing. We're still observing. Go for it. Yeah, go for it. Start adding some bubbles and see if there's anything different from the air that you exhale than the air in our room. Yeah, there it is. Not so much change yet. Oh, Carrie mentions, and Claude and a few others are mentioning carbon dioxide. Yes, you're putting carbon dioxide. There's Carrie's note. Carbon dioxide is changing, and we're getting a slight color change. It's turning, it was a little bit of a greenish blue before, and here we are, and it is a different color. Andrew's class at airport also says carbon dioxide. Thank you. Now lift that on up and show the students and the viewers. Excellent. So we had a change. So what's happening is the carbon dioxide that Mandy was exhaling in a small amount, of course, nothing dangerous, was creating carbonic acid. And that carbonic acid was obviously evidenced by when we saw the color change, by the indicator telling us there's an acid in there. I can do another smaller version of that, maybe faster with this one right here. What I have in my hands is some dry ice. Now, this dry ice is actually frozen carbon dioxide, so very similar to what Mandy was doing. And I'm going to place it inside this one here. We're going to see the same thing happening. So, oops, there goes a couple pieces there. I'll put that back in. So dark blue transitioning slowly, actually a little quicker, because there's more of it in that dry ice, to yellow. And there is our example of acid rain. Now, of course, whether that carbon dioxide is too much of it, there's a lot of it, for example, with this carbon dioxide, that can affect our ecosystem. So we want to keep the air clean, and keeping the air clean and the oceans clean and all our water systems clean means making sure we reduce those our carbon footprint and our greenhouse gases by taking a bike. Now, we want to keep this water clean, and water is one of the other challenges, wasn't it?
Yeah. So actually, our very first week, we went and we focused on our Power by Water Challenge, which really was looking at water usage and just changing our habits to, like, when you're washing your hands, turning off that tap, or just taking like a 5-minute shower, like even just changing your laundry and going and having cold water instead of warm water. Did you know that heating the water for your laundry is almost 90% of the energy that goes into the laundry machine? Like, those little steps really do go a long way.
So we want to keep our water clean, and we want to use it efficiently because it's very special to us, right? Water is actually all over our planet, and it's one of the things that we need for weather. And it's one of the things we need to survive, of course. Where does all this water come from? Where does it all come from? Mandy, where do we get all this water?
Well, everywhere. It's come from the sky.
From the sky. Comes from the sky, comes from all kinds of places. I think it's about time we check back in with Ms. Seaver's class. And feel free on the chat to chime in with these answers. I feel like you know some of these that I'm about to ask, so let us know that you know them and celebrate your knowledge. So, Ms. Seaver's class, if you can come join us, I would like, if you have a student or a couple of students that would like to explain to me the water cycle, where we get this water that we want to keep so precious. Where does it come from? Where does it go? Let's learn a little bit about the water cycle together right now.
Okay, we have one person who's right beside me that would love to there, but too shy to go on camera. So how does the water cycle work, En?
Clouds.
Okay, what's happening up in the clouds?
Evaporation, condensation.
Oh, we got a couple of terms here. Evaporation, condensation, what it comes down? Precipitation. And then, yeah, you pretty much got it all. We just got to get it in the right order. Yeah.
So what I heard was evaporation, condensation, precipitation.
Yeah.
Awesome. Anybody else out there got those answers? I hear a few people. So basically, the water can start anywhere in the cycle. Though I'm going to do a quick demo with the water cycle, if that's all right with all of you. So water, I got a little cup here. I've got some water to put into that cup. And I've got my little lake down below, as you can tell. We got a landscape, a beautiful plastic tarp landscape. I'm going to pour my water into the cup. And there it is. And it's going to evaporate up into the clouds like that. And the clouds hold it. I mean, a lot of the air that is in our planet, the atmosphere, is also water vapors present. And with the right temperature, it gets stuck up in a cloud like that. I'm just going to turn that upside down. And when I said stuck up in a cloud, it does stay up in the cloud, you see. It does stay up there. So it hangs out at the top in the sky. When the time is right, and that depends on the atmospheric pressure and how much air and molecules have stuck together in that cloud when there's a lot of water in that cloud. And then the precipitation portion comes out in the form of rain like this. You see, it wasn't stuck. It was just waiting for the right atmospheric conditions to come down. Sometimes it rains a little bit, like some parts of our province and country, and sometimes it rains a lot. And so that's our rain and our water cycle. Now, at the beginning of the presentation, Ms. Sievert's class mentioned snow as well as an extreme weather condition. Now, it doesn't have to be extreme, although when we get 1 millimeter of it here in Vancouver, everybody kind of panics, which you shouldn't have to do that. So I've got a little demo, same thing. So the same water cycle goes up, down, and around, and snow happens when basically the water goes up and the atmospheric conditions happen to be just right for the temperature to be cool, the right temperature, the ice crystals to form. And of course, at that point, we have our snow happens. There you go. There's my snow demonstration there. And of course, if you live in Lower Mainland, you don't get, this is about as much snow as we get in a season. But some years we get more than others. And that's where that snowstorm and that extreme weather can kind of be a bit of a concern. Now, this might be what the snow looks like for some people. And for other people that are used to seeing, I think hail was also mentioned. Sometimes if it goes up, and depending on the size of those water droplets, when they're frozen in that temperature up in the clouds, or if they start as rain and then freeze along on the way down, they can actually turn into hail. Oh, where's my hail? Didn't get my hail. Hang on a second. I think my hail got stuck. Oh, there it is. So this might be what our snow in Vancouver looks like a little bit. Not so fluffy as the last one, more smushy like that. So you get all kinds of different precipitation, and that all is affected, of course, by the weather. And little changes in the weather can make a big difference between rain, snow, hail, or a lot of any of these things. And if you include storms with the winds that we were talking about, and tornadoes, all those make for some pretty extreme weather patterns. All right. Extreme weather patterns aside, we want to make sure we focus on the future, and sustainability, I believe, is one word we like to use a lot about doing the right things and keep doing those right things. What are some of those? I think that was one of the other challenges, wasn't it?
Yeah, actually, the last challenge that we gave was our sustainability challenge, in which we really focused on pushing ourselves to go and have towards that sustainability. It's creating those habits, like the no waste lunch, making sure that you're using reusable containers, as well as just reusable water bottles, and taking that challenge onto our own and really challenging our friends, our family, our community to do the same.
Do you have a reusable water bottle that you use all the time?
I do, actually. It's just off here at the side.
Do you decorate it a certain way?
I have stickers.
All right, who's got stickers on their water bottles? Put it in the chat. I want to know what the hot stickers are this season for water bottles and reusable containers. And I'm going to actually check in with Ms. Sievers and see where their class actually landed with their journey with this particular challenge.
Actually, this was one of the best challenges that we did the best on, because a lot of kids almost everybody has a reusable water bottle if they bring one at all. And most kids have a fairly waste-free lunch. Now, I was wondering, you know, when kids come with a Ziploc bag and with cookies or whatever, and then they take it home and reuse it the next day, I felt like that was sort of a no-waste lunch. So quite a few people were trying to do that with their lunches.
Right. They're little acts of change. And I think that the reality is that if we all do a little part, and even if it's not using one, let's call it disposable plastic thing more than once and we're using it, it is a small act that does add up. And so the pressure of making all this thing happen by ourselves is not the very achievable. But what we're learning from this Acts of Clean challenge, I think, is that if we all do a little thing and we build that up together and everybody does that, then we're all working together to a big thing. Like as Mandy pointed out, 37,000 acts of clean. I don't think anybody in each of these classrooms thought that they were going to be able to achieve that by themselves by any means, but here we are. I hear some great some comments about stickers on reusable water bottles and things. We've got Mandalorian, lots of stickers on bottles. There's one. And that's really cool. So taking pride in what you're doing is also a great way to do it. And like you said, Mandy, challenging each other to say, let's do this. And that means being kind with people and saying, hey, I do this. You can try to do what I'm doing as well. Instead of, obviously, we don't want to be judging folks. We want to work towards common goals.
Yeah, making sure that we go and we work towards conservation, because at the end of the day, all those little things, they're all going to add up and they're all going to help us in the end.
Yeah. So we've all done a lot of little things, and I think it's maybe a good time to celebrate the winners of the contest. What do you think?
Yeah, let's do it.
All right, so there was a lot of people that from all over the province that participated. So if you participated in this and you're very excited, and just cross your fingers and let's get ready to roll. We're going to announce the winners live here on the live stream. And what is the prize?
All right. So we actually have not just one winner, but we actually have two.
Mm-hmm.
So we've got a household winner and then a classroom and community. So the household winner is going to go home with a big prize pack of all these different gadgets to go and help you with conserving energy, as well as our grand prize winner of our community or classroom. They're going to win a pizza party. And we've got Dave from BC Hydro, who's going to go and have a little special welcome for you guys.
They get to meet Dave from BC Hydro and get a pizza party.
Dave. Yeah.
I wish I had gotten a classroom together and made a team. That would have been fun for me. But that sounds pretty exciting.
Yeah.
All right. So let's announce the household prize first.
Yeah.
All right. All right, folks. The household prize winner.
All right. We've got, from right here in Vancouver, Peter Mock.
Congratulations. Peter Mock wins that awesome box of equipment to help keep doing what they're already doing.
Yeah.
Amazing. I'm actually hoping that through the process of this challenge, that all of the folks out there have, and even this live stream, all the folks out there have been able to get ideas of ways that they can do this stuff. So we don't want to just end it here. We want to keep going. That's that sustainability point. Now you've got another envelope there for the class prize, right?
Yeah, we do.
All right, Manny, it's all yours. Let's find out.
All right. Well, they're from Coquitlam.
Oh, we have a few viewers from Coquitlam today.
Grade 6-7 class from Montgomery Middle School. Miss Severs' class? Wait, isn't that you guys?
Miss Severs' class. Let's cut to them right live. You're the winners of the Big Grand Pizza Party prize with Dave. Congratulations. That's right. That's you. That's awesome. Congratulations. Oh my goodness. That is awesome. Well, congratulations. You're going to be getting a visit from Dave from BC Hydro and a fancy pizza party. That's a great way to celebrate. That's awesome. Manny, you and BC Hydro have been doing a lot to support. Let's just see if there's any questions in the chat or any questions we have for each other. So we'll open that up right now, all our viewers. And Ms. Severs, if your class has anything to add, just please flag us and we'll bring you back in. Well, congratulations again. So folks in the studio here, is there any special questions that we may have noticed coming up throughout the chat that we would like to answer? Why does the liquid change color? What a great question. I'm assuming we're talking about this one right here. So of course, a lot of chemicals, whether that be water or any chemical on the planet, has their properties, and their chemical properties can be affected by other being in contact with other chemicals. So this particular chemical called bromoethyl blue has the trait that when it is turned into it's mixed with an acid, it tells us by changing its color. So things that are acidic include stuff like vinegar or carbon dioxide, and then it'll change color. So that's why we use it. Oftentimes we use these kinds of chemicals to balance our water, whether that's in a pool or a hot tub, or just to make sure the water systems for our city are clean. We use chemicals like this to understand what's in the water. You can't just look at it and know what's inside necessarily all the time. And this is a fast way for us to see that there is an acid was added to this water. I hope that answers your question. And hot tip, you can actually use cabbage juice to indicate acids and bases. You can look at Science World's website for that. I'll let you dig around for that cool nugget. Let's see, any other questions? Does the electricity used for a car last longer than using fuel? How do you feel about taking that one on, Mandy, as a question?
So just to repeat, it's...
Does the electricity used for a car last longer than using fuel?
Well, it actually depends more on the vehicle itself. So sometimes, especially with some EVs, you're able to get that real distant range. Right now, we've got a lot of technology that's building, and you're going to see more and more throughout the years where we're going to be able to kind of gain more of that mileage. Mm-hmm. But yeah, it's definitely on its way.
Yeah, it's hard to compare apples to oranges, in fact.
Yeah.
And inevitably, hybrid technology, so cars that use both electricity and regenerative braking and things like that, as well as fuel, is a way to get from one part to the other. So you're getting there, folks. For those of you who are a little younger, you may not remember, but there was a time not too long ago where electric vehicles were not something we talked about, and we're getting there slowly and surely, and even the infrastructure to charge them up and have them go further, like Mandy mentioned. What country has the most acid rain? All right. Now, the environment around the world, of course, is always moving. The air and the atmosphere is always moving. But of course, if there is a high concentration of carbon dioxide or other greenhouse gases, essentially, in a certain area, they tend to be the ones that gather that acid rain through the precipitation and the water cycle. And China and India are the ones that currently have a higher occurrence of acid rain. I'm very happy to report I've never heard of that in Vancouver, and I'd like to keep it that way. And that means all of us doing our part in those little ways. Let's see if you have any other questions. Grade 4 students, what is dry ice made of? I'm glad you mentioned that. Actually, I said it very quickly earlier. Dry ice is actually, I pull some out right here. Dry ice, there's some right here, is actually made of carbon dioxide. So what you are exhaling when you are watching the presentation going, I wish I had dry ice, is the same thing as the dry ice itself. So what's happening right now is that this dry ice is super cooled. I believe it's 180 below.
Minus 80.
Yeah, minus 80.
Yeah, not 100.
Oh, minus 80. Sorry, I added 100 there for a reason, no reason. Minus 80 degrees Celsius. Sorry. And it's very, very cold. And what's happening right now is the air in the room is room temperature, but it is much warmer than the dry ice, this carbon dioxide that is frozen. And it is sublimating, going directly from solid to gas. It's not going through that usual cycle of solid, liquid, gas, as we know when an ice cube, for example, might be warmed up to a higher temperature. So there's our dry ice example. It's carbon dioxide. Put that back. Hope that answered your question. Why is the tornado a funnel shape? That's a good question. The circular motion of the air that is meeting itself, hot air rises, cold air goes down, and so when it meets, it creates that spherical, conical shape, that motion that goes in a circle, and that circle naturally translates to that funnel shape. In fact, they called it a water funnel when it was over the water, that one that visited us in Vancouver recently, and then when it hit land, they classified it officially as the smallest possible power of tornado, but it did change, and the funnel was the shape that it did. just the physics of how that movement is. Let's see, is there any more questions before we wrap up today? Let's see here. I'm not sure if I have the answer to that. We'll see if we can find that. Let's see. How many households will the new Site C dam be able to power? Asks Andrew Clark with a wink. We've got some fast-moving folks here behind the scenes at our live stream. We have 450,000 homes, 5,100 gigawatt hours. That just sounds like a lot, doesn't it? The little infrastructures that we put in to our world today, whether that's acts of clean or infrastructures for electric vehicles or even power sources, are things that we can then take advantage of and use in the future, and that's still underway, of course. Let's see. Is there any other last questions? Burning questions? Mandy, do you have any questions for me?
Yeah, actually, how did you make it rain?
How did I make it rain? I'm glad you asked that. This is a little bit of a trick here. What I did, and you can do this one at home too. I love to offer some do-at-homes. If you have a little bit of a mesh that you can get at a hardware store or buy it from a used screen door, all you're going to need to do is affix it to a cup, pour some water in, and then hold it upside down. But you're going to want to sort of lock it in place first. And when you're doing that, what's happening is the air pressure from all around the cup is actually holding everything in place. When I remove that lid, which eventually falls from gravity, you'll notice that the water doesn't fall. And the reason it doesn't fall is because water has what we call surface tension. It's a bit sticky. The water molecules are a bit sticky, and they're sticking to each other, and they're all trying to get through this mesh at the same time because they're being pulled down by gravity at the same time. Now, when I give it a little extra push, it makes it rain a little bit because there's some water and the air pressure is changing, just like in our weather. But basically, they're trying to all get at the same time. They're getting stuck on those little squares. And you can definitely find how to do this experiment and other cool demos around water and air pressure at Science World's website. There's a type in resources or just go poke around our fantastic list of demonstrations that you can do in the classroom or just at home on a rainy day. If you want other resources, of course, Hydro knows that they've got lots of great stuff.
Yeah, you can check out our conservation hub at bchydro.com/conservation.
Awesome. I'd like to just tune back in with our classroom. Are they still there? Awesome. One last big congratulations, Ms. Sievers and your class. Congratulations on being the winners of the Acts of Clean. Big round of applause for yourselves. We're giving it out to you here from the studio. And a big round of applause to all our participants in the Acts of Clean Challenge with BC Hydro. And really proud of all your small but very impactful accomplishments. Andy, any last words?
Thank you so much for actually letting us be here at Science World today, actually.
Oh, it's a pleasure. Always fun to play with our friends from BC Hydro. Thanks, everyone. Keep doing science, keep asking questions, and keep doing some great acts of clean as you go onward and be the future we love. Thank you so much.